Hi, welcome to the Mathemagic channel. Today we look at how we can use the quadratic formula. And this is a formula that is absolutely wonderful and that has been torturing students for years. So let's make sure that this is really helpful so that you guys can know how to use the formula, know when to use it, know the ins and outs of it, and really get down to what it means and have a complete understanding. Our aim is by the end of this video that you really understand this formula. So let's try it out. What is the quadratic formula? So it's a formula that you can use when you have trouble factorizing, or simply put, whenever you cannot solve a quadratic, you should be using the formula. You can use it in the real numbers, you can use it in the complex numbers. It's a formula that always works, so it's super useful. So here's the quadratic formula. If you have a quadratic ax squared plus bx plus c and it's equal to 0, and you're looking for those zeros or looking for those solutions, the quadratic formula is x equal minus b plus or minus the square root of b squared minus 4ac divided by 2a. Now, the first time you show this to any student, they'll be pulling their hairs out. But when you break it down, it's actually not that bad. So let's try and do that today. What are a, b, and c? These are the coefficients of a quadratic in general form. You'll notice that if you have a quadratic like y equals x squared minus 5x minus 6, the coefficients are the numbers which go in front of x squared, in front of x, and the constant at the end, which is the whole number at the end. So here you have 1x squared, because you still have 1x squared, you don't have 0x squared. You have negative 5x's, and the number at the end is negative 6, which is the y-intercept. And your coefficients are going to be a equals 1, b equals negative 5, c equals negative 6. These are the a, b, and c's which we use in the formula. If we look at another example, y equals negative 3x squared plus 2x minus 9. If you try and find those coefficients, you'll realize, and we've highlighted them in red for you here, a equals negative 3, b equals positive 2, and the c value is negative 9. So there's b and there's the c value, negative 9. So they're not too hard to figure out. It's just the numbers, first the number in front of x squared, then the number in front of x, and then the last number. Back to that formula, so that super scary formula. Now, you'll notice in that formula, there's a bit that's under the square root, which is the square root of b squared minus 4ac. This is going to become super important. Why should we focus on the part under the square root? Well, there's something in mathematics, which is the fact that you can only take the square root of a positive number. So if you try and square root 4, you get 2. If you try and square root negative 4, you get a math error. You can try and use it in your calculator, and your calculator is going to compute E. It's going to say math error. That is because there's no number times itself which is equal to negative 4. If you do 2 times 2, you get 4. If you do negative 2 times negative 2, you also get 4. So the only way that you can have a number times itself and make it equal to negative 4 is if you have one positive 2 and one negative 2. And the concept of squaring is the opposite of square rooting. So squaring and square rooting are opposite concepts. So square rooting a negative number leads to no solutions. How does this affect the square root of b squared minus 4ac? The bit under the square root, the b squared minus 4ac, must be positive. So we actually call this quantity the discriminant. And it's very important to analyze this before you do the whole quadratic formula. You should do the b squared minus 4ac bit first to make sure that it's positive. Otherwise, the equation is a math error. So if b squared minus 4ac is negative, the equation's an error and there are no solutions. So we call b squared minus 4ac delta, which is the Greek letter D, and we actually call it the delta test. And so delta is the Greek letter D, we call it delta. And we're going to use it, and we're going to say delta equals b squared minus 4ac to figure out how many solutions our quadratic really has. So let's explore b squared minus 4ac here. So we'll put the quadratic formula up above on the right. So we have 3 cases for delta. If you think about it, a value can either be negative, or it can be positive, or it can be equal to 0. And this is going to happen with b squared minus 4ac. If the delta value, or the b squared minus 4ac bit, is positive, you will have the square root of a positive number, and the quadratic formula is going to work. And so therefore you're going to have two solutions. And remember, solutions are points of intersection with the x-axis. So they're going to be two values where that quadratic equation is intersecting with the x-axis. If the delta value is equal to 0, we're going to have just one solution. And I'd like you to refer to that formula just above my head here. You'll have minus b plus or minus the square root of 0 divided by 2a. Now the square root of 0 is 0. So you're just going to end up with minus b divided by 2a because the square root of 0 is just going to go away. And that'll just be one solution, negative b over 2a. So this is really important. Whenever you have delta equals 0, you have one solution. That doesn't mean you don't have a curve. You have a curve just as usual, but instead of crossing the x-axis and intersecting twice, it just sort of sits on it and it just touches it once. So you can see on this graph here, we just touch the x-axis and we don't go through it, which means we just touch it once. That's when delta is equal to 0. If delta is negative, we don't have any solutions. We're going to have like the square root of a negative number. That's going to be a math error and the whole thing explodes and there are no solutions. Now, that does not mean you don't have a curve. You absolutely have a curve. There is still a drawing. There's still like a mapping of x values and y values. There's still an umbrella shape. There's still a parabola. But that parabola is a little bit too high and it doesn't cross the x-axis. Or it could be a little bit too low and it could be under the x-axis. It just means there are no x-intercepts. But everything else still works. It's still a drawing. It just means you can't find values for which it crosses the x-axis. And that's okay. It happens sometimes. Let's look at this in more detail. So here's the quadratic formula. Let's learn to calculate delta. We can take a few equations and just learn to calculate it so we familiarize ourselves with it. And the conclusion. So remember, positive, two solutions equal to 0. One solution, negative. You can stop right there. There's no solutions. So let's look at this first case. Y equals x squared plus 5x plus 6. Remember how to identify the coefficients. It's 1x squared, 5x's, and 6. So the a value is 1, the b value is 5, the c value is 6. And so these are good. Now we need to do b squared minus 4ac. So b squared will be 5 squared. 5 squared is going to be 25. And then you need to do minus 4 times 1 times 6. So remember, multiplication comes before the subtraction there. So the 4 times 1 times 6 is going to be a block, which is, in this case, 4 times 1 is 4, and 4 times 6 is 24, and it's going to be negative 24. So you're going to end up with 25 minus 24. And 25 minus 24 is 1. And you can conclude here, okay, my delta value is positive. 1 is a positive number. And therefore, I will have two solutions. So you should have two separate intersections with the x-axis. Let's check out another one here. X squared minus 4x minus 12. So the a value is 1, the b value is negative 4, the c value is negative 12. Again, we're going to do b squared, so negative 4 squared. Now, negative 4 times negative 4 is 16. So negative times a negative, or negative squared, it becomes a positive. So negative 4 squared is going to be 16. And then you have to do minus 4 times 1 times negative 12. So minus times minus is going to be plus. So it'll be 4 times 1 times 12, which is 48. So we end up with 16 positive and 48 positive. And 16 plus 48 is 64. 64 is a positive value. Therefore, delta is positive, and our equation will again have two solutions. Let's look at another case. Here's another equation, x squared plus 10x plus 25. The a value is 1, the b value is 10, the c value is 25. So learning to identify your coefficients is really important. We're going to do b squared, so 10 squared, minus 4 times 1 times 25. So 100 minus 100. Oh, that's 0. Well, when delta is 0, we still have a solution. We call it a double root. And we're going to have one solution. So the square root of 0 is 0. It still works. But we just have one solution. So we're just kind of sitting on the x-axis, right? Let's look at the next one here. X squared plus 3x plus 5. Okay, so a is 1, b is 3, c is 5. Seems reasonable. And so we're going to do 3 squared, which is 9, minus 4 times 1 times 5. So 3 squared minus 20. So 9 minus 20. That's negative 11. Oh, that's a negative square root situation. Delta is negative and we'll have no solutions. You can stop right here. There are no solutions to this quadratic equation. That does not mean you won't have a graph. You will absolutely have a graph. You can still put this in Desmos on your graphic calculator. It just means that you're not going to have 2 points of intersection with the x-axis. So just be aware of this. When delta is negative, you can stop right here. And I would really recommend that you work out the delta value first instead of just plugging all the numbers into that big formula. Because sometimes you're going to have no solutions and there's no point in continuing. So it's really important to do delta before you do the quadratic formula. I see a lot of students just writing the whole formula out and putting all the numbers in. Don't do that. Just figure out the delta value first, and that'll save you a lot of time. And as you can see here, we definitely have a curve. So this does not mean no curve. It just means it doesn't cross the x-axis. With all this in mind, let's actually look at the formula. So here's the formula. First we find delta, then we find the two solutions. Let's do it. So if we look at y equals x squared plus 5x plus 6, we're going to say 1x squared, 5x's and 6, a is 1, b is 5, c is 6. We work out the delta value. 5 squared minus 4 times 1 times 6, 25 minus 24. We did this one earlier. Delta is 1. It's positive. We have two solutions. And so we don't just stop here. We're going to now work out these two solutions. So if you look at the formula, which is right above, it's minus b plus or minus the square root of actually delta, b squared minus 4ac over 2a. So you can replace the b squared minus 4ac in this case by 1, since we worked out that it was 1. So it's going to be minus b plus or minus the square root of delta over 2a. This formula becomes a lot easier when you do b squared minus 4ac first. Now the square root of 1 is 1. So that's nice. The b value is 5. So it's going to be negative 5 plus or minus the square root of 1 divided by 2 times a. And a is 1, so divided by 2. So minus 5 plus or minus 1 divided by 2. And we can work out these solutions individually, and I would recommend you always work out the negative one first. That means negative 5 minus 1 should be the first one you work out, divided by 2. So minus 5 minus 1 is minus 6. Minus 6 divided by 2 is minus 3. Why do we work out that one first? Because it's more on the left. And if you think about x1 and x2, they're going to be numbered in order. So the leftmost should be the first one, should be x1, and x2 should be the second intersection. So negative 6 divided by 2, and then negative 5 plus 1 is going to be negative 4 divided by 2. Negative 6 divided by 2 is negative 3. Negative 4 divided by 2 is negative 2. You can work those out if you're not too sure. And if you look at the graph, you'll see that the two x-intercepts are negative 3, 0 and negative 2, 0. So this is what the graph looks like. Let's do another one. Again, we find delta first and then the two solutions. This time it's x squared minus 4x minus 12. We also worked out the delta value for this earlier, so we still have it. 1x squared minus 4x minus 12. A is 1, b is negative 4, c is negative 12. We're going to do b squared, so negative 4 squared minus 4 times 1 times negative 12. So 16 plus 48. Remember, we worked this out not so long ago. That's 64. That is positive, so we have two solutions. And remember, we use the square root of 64, which is 8. In our formula, we're going to have minus b. So let's be careful here because b is negative 4. Minus b is going to be positive 4. So that's going to be pretty important here. So here's your formula, minus b plus or minus the square root of delta over 2a. So 4 plus or minus the square root of 64 over 2 times 1, which is 2. So 4 plus or minus 8 divided by 2. Now I would recommend you do 4 minus 8 first, which is negative 4. Negative 4 divided by 2 is negative 2. And then 4 plus 8 is 12. 12 divided by 2 is 6. So these are your two solutions. And if we look at the graph here, we have 2 points of intersection with the x-axis, negative 2, 0 and 6, 0. So the formula is good and we're pretty happy. We can move on to the next one. What if a isn't just 1? Like what if we have 2x squared or 3x squared or 4x squared? Well, the formula still works. So we need to know how to deal with that case. So if we have 3x squared minus 2x minus 5, nothing changes. We still have the coefficients. So 3, negative 2 and negative 5. So a is 3, b is negative 2, c is negative 5. we're going to do negative 2 squared, which is 4, minus 4 times 3 times negative 5. So when you do negative 4 times 3 times negative 5, a negative times a negative is a positive, and that block will be positive. So all you have to worry about is counting 4 times 3 times 5. 4 times 3 is 12. 12 times 5 is 60. So that's okay. So we're going to get 4 plus 60, which is 64. And that's a positive value. So again, we're going to have two solutions. The square root of 64 is 8. It's a perfect square, so that's beautiful. Works out really well. x1, x2 are going to be minus b plus or minus the square root of delta over 2a. Minus b will be positive 2 because b is negative 2. And then plus or minus the square root of 64, so plus or minus 8. And then now this is the difference. You have to think that 2a is 2 times 3. So that's 6. So you have to be a little bit careful here. It's not always just divided by 2. It's divided by 2a. So just be aware of that. That's the difference. And as we do this, we get 2 plus or minus 8 divided by 6. And 2 minus 8 is negative 6. Negative 6 divided by 6 is negative 1. 2 plus 8 is 10. 10 divided by 6 is 10 over 6. That simplifies nicely to a fraction of 5 over 3, which is 1.6 recurring. And if we go ahead and look at the 2 points of intersection on the graph, we'll realize we have negative 1, 0 and 1.6670. So I know this might look a little bit small here, but negative 1 is the first value and 1.666 is 5 over 3 is the second value. So if you've made it this far in the video, you probably have a really good understanding of the quadratic formula, and we're going to explore now if the values aren't very easy to handle. That can happen when you don't have a perfect square, when you do the delta value. So you're going to have to be a little bit comfortable with surds. If you're not too sure about how to handle surds, I really recommend you go and watch our video on surds. It'll be very helpful to you. So the formula still works. Let's look at x squared minus 2x minus 7. Doesn't look very easy to factorize. That's because negative 7 doesn't have a bunch of factors. It's just got negative 7 and 1, or 1 and negative 7. So we decide to go ahead and use the formula. 1x squared minus 2x minus 7, a is 1, b is negative 2, c is negative 7. We're going to do negative 2 squared minus 4 times 1 times negative 7. The negative 2 squared is 4. 4 times 7 is 28, and it's going to be positive because it's a negative times a negative. So we end up with 4 plus 28, and we end up with 32. 32 is not a perfect square. So if you do the square root of 32, that doesn't return a perfect square. But it is the square root of 16 times the square root of 2. And the square root of 16 times the square root of 2, again, refer to our surds video, is going to be 4 root 2. You really need to be comfortable with that. So it's still a positive value. It has two solutions. And if we look at the square root of 32, you can simplify it to 4 root 2, taking out the square root of 16, which is 4. Root 2 is stuck inside. And that's okay. That's absolutely fine. You should be happy working with surds. So please don't go ahead and find the decimal solution. It's really important that you keep the exact value, because your paper might ask you to retain the surd form or the exact value. So make sure that you don't simplify this in your calculator. Otherwise you might get the question wrong. So we just need to be happy working with surds here. And x1, x2 is minus b plus or minus the square root of delta over 2a. Negative b is going to be 2. So 2 plus or minus 4 root 2 divided by 2. Now everybody is divided by 2. So 2 divided by 2 is 1. And 4 root 2 divided by 2 is 2 root 2. So this is going to lead to 1 plus or minus 2 root 2. It is very important here, if you're not too sure how to deal with those numbers, to have an awareness of what root 2 actually means and what it is. Okay, so for our solutions, we have 1 minus 2 root 2, which is going to be the negative solution, and 1 plus 2 root 2 is going to be the positive solution. And so your graph looks a little bit like this. Our two values are negative 1.828 and positive 3.828. And to get a better understanding of this, it's important to know what root 2 actually is. So the value root 2 is 1.414. The square root of 2 is actually a decimal value. It's just 1.414. You can type that in your calculator and check it out. It's not exactly that. There's a string of decimals after it, but the first 4 digits are 1.414. If you were to multiply that by 2, so when you say 2 root 2, you get 2.828. So that's a number. 2 root 2 is 2.828. Or, the square root of 8. Actually, it's the same thing. And so this is pretty important, because if you do 1 minus 2.828, you get that first solution, negative 1.828. And if you did 1 plus 2.828, you get that second solution, which is 3.828. So go ahead and mess around with that on your calculator to realize that root 2 to root 2 are decimal values, and you can absolutely treat them like a normal number. It just means that they're a little bit awkward to deal with because they're decimals. But it doesn't mean to say that you should stop there and be scared. Root 2 is about 1.4, and you can deal with it. You can double it. If you double it, it's about 2.8. It's not too bad, right? Thank you for watching this video on quadratic equations. If you're not sure about any of the content that was covered today, watch the video again. I'm sure it will make sense eventually. Make sure you practice plenty. You need to practice the discriminant, the b squared minus 4ac value. It's very important that you also practice doing the whole formula from start to finish with maybe 4 or 5 examples. We'll make sure to include a worksheet in the description below so that you can practice the quadratic formula. And please like and subscribe to the Mathemagic channel so we can keep delivering you these awesome lessons to support your learning at school and in mathematics in general. Thank you so much, and we'll see you on the next video. Bye-bye.